Okay, one more thing here. A nice analogy to NMR is a gyroscope, because of course the protons in the hydrogen atoms are gyroscopes. They have angular momentum, and they also have charge. And whenever you have angular momentum and charge, you have a magnetic moment. Okay? So some of the behavior we're looking at, we can understand by looking at this gyroscope. Here's the gyroscope. We can imagine that this is the low energy state of, this is the state that corresponds to the low energy state of the spins, spin down, okay? Here's the configuration that corresponds to the high energy state, spin up. Interestingly, to switch from spin down to spin up or to any other orientation, we can do this by applying an excitation pulse. When we apply an excitation pulse, the spin vector will start to rotate in this plane. And we can rotate by 90 degrees and get a pi/2 pulse, or 180 degrees and get a pi pulse, or we could keep going even, do 360 degrees and get a 2 pi pulse. Now here's something interesting. If we prepare the system in the low energy state and leave it, nothing happens. It's in a static state, okay? Likewise, if we have prepared in the high energy state and leave it, nothing happens. The system is in a time-independent state. Not very exciting. So both the low energy state and the high energy state are stationary states, of course. But what if we set up the system like this, after a pi/2 pulse? Now it's in a superposition, the quantum analog is a superposition of the ground and first excited states. If we release the system here, something interesting will happen, okay? Now it's easy to see what happens classically. The magnetic field acts on the magnetic moment of the proton and produces a torque, mu cross B. We can apply a torque to this gyroscope by applying these weights to the axis of the rotator. And let's see what happens when we release it. Of course, what happens is that the gyroscope starts to precess, and the spin starts to circle around in the XY plane. This is the state that produces radiation. Imagine all of the protons in all of the hydrogen atoms in that sample of mineral oil being excited by a pi/2 pulse. After that pulse, they all start to rotate together. And then this rotating magnetic moment produces a magnetic field that sweeps through space like this, rotates essentially. Our pickup sensor, our pickup antenna is a coil that's mounted in space. And as the magnetic field sweeps through the coil, the magnetic flux through the coil changes in time. And so, of course, that induces a voltage across the coil. That's the signal that we pick up. So we don't see radiation in the ground state. We don't see radiation in the excited state. You only see radiation in a superposition state, like this 50-50 superposition. Something else you can see for this gyroscope system, because there's some friction, after a while, the axis of the rotor starts to point further and further down. It's being acted on by the torque, and that slowly changes the direction due to friction. Well, the same sort of thing is happening in our spins. Because of spin relaxation, energy relaxation, the spins will eventually end up back down at the ground state. Okay, perfect.